An acid is a substance that will release hydrogen ions into the solution. So here's an acid placed in water. What happens is this acid begins to break off these H pluses, which are ions, cations in this case, hydrogen ions. So the more hydrogen ions there are floating in a solution, the more acidic the solution is. A base, or an alkaline, is a substance that will release hydroxide ions into the solution. A hydroxide ion or hydroxyl ions are OH negative, oxygen, hydrogen with a negative charge. So the more OH negatives, the more hydroxyl ions are in this solution, the more alkaline or basic the solution is. Here is a pH scale. A pH scale measures how acidic or how basic or alkaline the solution is. Right in the center of the scale, number 7 is neutral. So distilled water, pure water, is neutral on the pH scale. Any number less than 7 is acidic. The lower the number, the more acidic the substance is. You can see battery acid is pH 0, which is as acidic as you can get. If the number is greater than 7, it's basic or alkaline. The higher the number, the more alkaline the solution is. Liquid drain cleaner has a pH of 14. That's as alkaline or basic as we can get. And we see everything else in between. Now something to note here is the more acidic the substance is, the more hydrogen ions there are in the solution. The more basic a substance is, the more hydroxyl ions there are in the solution. This pH scale is not linear. It's logarithmic. You don't have to understand this equation here, but what you should understand is that each step you take is not a step of 1 like the numbers suggest. It's a 10 times difference. So if I were to ask you pH 3 versus pH 4, which is more acidic? Well, pH 3 is more acidic than pH 4 because the number is lower. How much more acidic? Not 1 more acidic, it's actually 10 times more acidic. So every step that you take increases the acidity by a factor of 10 if you're moving down on the scale. If you're moving up, it increases in alkalinity by a factor of 10. So knowing that, let's do this question here. It says pH 2 is blank times more acidic than pH 5. So we can agree that pH 2 is more acidic than pH 5 because it's a lower number. There's more hydrogen ions floating in solution. But how much more acidic if every step is a 10-fold increase in acidity? The answer is not 30, like we might think. How many steps are we taking? 1, 2, 3. That's 10 times 10 times, sorry about that, 10. What's 10 times 10 times 10? 1,000. So every step that you take, you add a 0, like you can see there, to the 1. And we get pH 2 is 1,000 times more acidic than pH 5. So basically subtract the two numbers and that's how many zeros go after the 1. In our bodies, we need to maintain this narrow range of pH. Homeostasis comes in and negative feedback. Our blood is basic because it's above 7. You might think it's slightly above 7, but remember every step is a 10-fold increase. So this is greater than neutral by a good margin. What happens if your blood gets lower than pH 7.35? Well, they call that acidosis. What if your blood gets greater than 7.45? They call that alkalosis, which are dangerous conditions in your body. So your body uses negative feedback to maintain this normal range of pH. How does it do that? Well, through buffers. If your blood gets too alkaline, well, the buffer will start adding hydrogen ions to the solution to make it more acidic. If your blood becomes too acidic, or towards the acidic side, less than 7.35, buffers will add hydroxyl ions to the solution to bring it back up to that normal range. And that's negative feedback like we saw in Chapter 1.